screen visible? Can you see the screen?
Yes, sir.
Okay, so what we discussed last time, if function is f is continuous at a and g is continuous at b is equal to f of a, then composition is continuous at e. Right. So this is what we discussed last time. So from this result, so from above result, so what we can see is, so let f of x is equal to x, and suppose I take x greater equals 0. So what is domain of this function? What is domain of this function?
Positive real numbers.
Positive, right? Or so domain of f is, as I mentioned, it is 0 to infinity, so non-negative integers, right? So let g of x is equal to square root of x. Now, what is domain of this function? For what
Non-negative.
values of x? Right. So x greater equals 0. So domain of g is 0 to infinity. So let, so is, so question is g continuous on set B? Domain of g is B. Is g continuous? Yes.
Yes, sir.
Yes, right? So why it is continuous? How will you prove that it is continuous? So for c greater than 0, f is continuous, g is continuous at c. How will you prove that g is continuous at c? Yes, how will you prove this? Yes, that is limit x tends to c, fx is equal to gx is equal to g of c, or limit x tends to c, root x is equal to root c. Can you prove this?
Yes, sir.
Right, so proof is straightforward. So given epsilon, want delta such that, right? So given epsilon, can you produce delta such that whenever distance of x from c is less than delta, then distance of gx from GC, which is root x root c, is less than epsilon. So, how would you do this? Yes, c is here and x tends to c, right? So, given epsilon, want to find delta. So, consider x minus c. So, what is x minus c? Root x square minus root c square. Is it correct? This is same as
Yes, sir.
root x minus root c, root x plus root c. I can split this. So, this is same as root x minus root c into root x plus root c. So, that therefore root x minus root c is equal to x minus c upon root x plus root c. Here x and c are positive, so the denominator is positive. But can you make root x minus root c less than epsilon? Right? So observe that here x is greater equal 0. Therefore, root x is greater than 0, and hence root x plus root c is greater equal root c, and I am assuming c positive, right? Therefore, 1 upon root x plus root c is less than or equal to 1 by root c. Am I right?
Yes, sir.
Yes.
Right. Therefore, can I say that root x minus root c, which is x minus c upon square root of x plus square root of c, since here I am not using the absolute value sign in the denominator because I know that everything is positive, so this is less than or equal to 1 by root c. So c is constant, right? We are talking about particular points, so x minus. Okay, now can you tell me what is a delta for epsilon? Right, this is
Into root C.
so this is gx minus gc, and I want what I want this quantity to be less than epsilon. Means what? I want this quantity to be less than epsilon. Means what? Root x minus c less than root c into epsilon. So this, from this I can guess what could be my possible delta. So choose delta is equal to root c into epsilon, right? So therefore, if distance between x and c is less than delta, then distance between gx minus gc, which is x minus c upon root x plus root c, right? Or let me add one more step here. So this is root x minus root c, and as we saw, this is x minus c upon root x plus root c, which is less than or equal to 1 by root c x minus c. But x minus c is less than delta. But delta is what? Root c epsilon, which is epsilon. So therefore, given any epsilon, we can produce delta. And thus, if c is positive, then g is continuous at c. Next, if c is equal to 0, then prove that limit x tends to 0 Here we are interested only in right hand side limit, right? Because our domain is positive, so not negative. So we can approach from the right side only. So g of x, prove that it is 0, which is root of 0. That means g of 0. So that you can check. Therefore, this function is continuous, right? So g of x is equal to root x is continuous. So now we want to generalize this idea. What is the idea? So let f of x is equal to sin x. X belongs to R. A is equal to set of those real numbers at which f of x is greater equal 0. Right? Now questions I would like to ask, is f continuous on R? Is this function continuous on R? Everywhere on R?
No, sir.
What is your answer? Sin x. Sin x is continuous everywhere, right? Now,
Yes.
so is f continuous on set A? Yes. Or more generally, if f is continuous on some set D and E is subset of E, then can we say that f is continuous on E? What is your answer? If
Yes.
function is continuous on bigger set, and I am just talking about smaller set, when I say function is continuous on D, means it is continuous at every element of D, right? Now E is a subset, so of course f is continuous on at every element of E. So answer is yes, right? Therefore, what is the answer of previous question? What is the answer of question 2?
Continues on.
Continuous.
Right. Now, here what is set A? What is set A on which function is non-negative? Sine function. If you see the graph of sine function, at which part, on which part sine function is positive? Do you see the figure?
Yes, sir.
Right. On which part this function is positive?
From even multiple of pi to odd multiple of pi.
Right. So on this part, this red color. Therefore, what is set A? So here, what is set A? So if you go to the negative side, so minus pi to minus 2 pi and so on. So all these intervals. So 0 to pi union 2 pi to 3 pi and so on. Union with minus 2 pi to minus pi. Union with what?
Minus 4 pi to minus 3 pi.
Minus 4 pi to minus 3 pi, and so on. You can take this union. Right, so do you understand what is our set A? On this set A, certainly f is continuous. So now let g of y is equal to square root of y, right? This is defined on non-negative values of y, right? So what is the domain? Domain of g of g. So domain of g is 0 to infinity, correct? So now note that if you look at function f from a to r, now what is our set? This set, f of x is equal to sine x, right? And b is equal to 0 to infinity. Then can we say that f of x belongs to b for every x in a? Is it true?
Yes, sir.
Yes, sir.
Now, can we think about, see, what is the situation? So this is my set A, some part, right? This is my set A. So these intervals, or let me draw in some different way. So whatever is my set A, I am applying function f on A. I have this interval 0 to infinity, and where is f? F lies here, f of x is here. If I take x from A, f of x is on positive side, right? Can I apply g? What is the domain of g? 0 to infinity. So can
B.
I apply, right? So can I apply g on every
Yes, sir.
point, right? Now can I
Yes.
apply a g on fx? Is fx in the domain of g?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So therefore, what is a composite function?
G of f continues.
Same. G composite f is a function from A to R. So what is g of f of x? G of g applied, so g composite f of x on x. So what is it? G of y. What is y? Y is
Root
fx.
sin
I'm
x.
root of y, but y is fx. So root of fx. So it is root of sin x. This is my function. And what is the domain of this function? A. Now question is g composite f continuous on every point of A?
Yes.
Yes. What is the answer? Yes.
Yes, sir.
Because so for every x in A, f is continuous and g is continuous at y is equal to fx. Whatever x you select, and therefore g composite f is continuous at x belongs to A. Right, and therefore where the sin x, square root of sin x is continuous, right? And therefore, what which question we answered? At what points square root of sin x is continuous, correct? So let fx is equal to uh, function we should take. So let fx is equal to x square minus 1 g of y is equal to absolute value of y, and h of x is equal to absolute value of x square minus 1. These are three functions. Then determine the set of points at which h is continuous. Right? So what is the simple observation here?
H is
Observe that,
continuous over R.
right, observe that h of x is, so what is simple observation? What is g composite f of x? So f is from R to R, g is from R to R, and what is g composite f is from R to R. So g of fx, right? And what is it? What is fx? What is g of y? What is g of y? G of y is absolute value of y. G of any value is absolute value of that. So g of fx, whatever is the number fx, g of that number is absolute value of fx. But fx is x square minus 1. So therefore it is hx. That means hx is just composition of these two functions. And when we want to understand continuity of h, that means we want to understand continuity of f and g. Right? So therefore, since f is continuous at every x in R, and is g continuous
Yes, sir.
at
Yes.
every y in R, and therefore no matter what is f of x, you choose, right? So you just choose, this is a domain of g, right? So this is domain of f, this is domain of g, and whatever x you select, right, f is continuous, and wherever this f of x go, no matter, g is continuous everywhere. So wherever this f of x go in B, no matter, g is continuous, and therefore composite function is continuous. Therefore g composite f is continuous at each x in R. Right? So therefore absolute value of x square minus 1 is continuous everywhere. That we can understand immediately from this. Right? Okay, now let us make this idea more general. So suppose A is a subset of R, any subset, and f from A to R is a continuous function. Right? Suppose f is a continuous function defined on this state. So let n is a natural number. So define g from R to R by g of x is equal to f of x raised to n. This is my function. I am defining a function which is nth power of fx. Do you understand what kind of function is this? Yes.
Yes,
For
sir.
example, so let f of x is equal to sin x into e raised to x, and n is equal to suppose 3. and g of x is equal to x, q of x is f of x raised to 3. That means e raised to 3x into sine cube of x. And now we are interested in continuity of g, right? So given that f is continuous, what about g? The
We
question
can try to
is,
find out h of x such that h of f of x is equal to g of x.
yeah, so let hx is equal to x raised to n. N is some number, right? I am not changing n. N is some number, right? And on which set x belongs to R. So now question is h continuous?
Yes, sir.
X to the power n. Yes, why? We have already discussed this is polynomial, right? So h is continuous everywhere. So what is the domain of f? Domain of f is some set A, and this is R, right? And this is R. Here we have a function f. Now I am looking at function h, and h is defined on R, right? H is defined on R, and h is continuous everywhere, no matter. Now if I take x here, then f of x would go here. Let us call it as y. So is h continuous at y? Is
Yes,
h
sir.
continuous at y? Yes, because h is continuous everywhere. So at y also no problem, it is continuous. So therefore, what is h composite f of x? What is it? H of fx. But fx is y, let us say y, then it is h of y. But what is h of y by definition of h? It is y raised to n. That means f of x raised to n. And this is true for every x in A, no problem, right? And therefore this is nothing but gx. So now okay, let us define. Yes, so H composite F is actually Gx. And now we want to discuss continuity of G. What was our question? What was our question? Is G continuous on A? Right? This was our question. But what is G? G is actually composition of F and H, and therefore to understand continuity of G, we need to understand continuity of H and F. Yes, correct? Am I right?
Yes, sir.
So given that f is continuous at each x in A and h is continuous at y is equal to fx for every x in A, therefore by previous theorem, E is equal to h composite f is continuous at each x in A. Correct? Do you agree?
Yes, sir.
Yes.
And therefore, as an application of this, prove that f of x is equal to sine raised to 2021 x is continuous. on R. Is it true?
Yes, sir.
And what is the reason? Because sine f of, we can think of it as a composition of two functions, sine x and x raised to 20, 21. And both are continuous everywhere, so no problem. This function is continuous. This is a simple reason, right? Okay, so let fx is equal to greatest integer function. Right? Now you know what is greatest integer function.
Yes, sir.
Yes, sir.
Greatest integer less equal x. That means look at all the integers less than or equal to x and which is the greatest. Right? That means if I choose any x and you look at all the integers less equal x and which one is the greatest, choose them. For example, what is f of 1.5?
1.
Right. 1, because if you look at 1.5, what are the integers less equal 1.5, 1, 0, minus 1, greatest is 1. Right. So what is f of 3?
3.
Right. Now 3 itself is integer, and what are the integers less equal 3? 3, 2, 1, and so on. But 3 is greatest, so it is 3. But what is f of minus 1.5?
Minus 2.
Minus 1.5 minus 2. Now look at minus 1.5 and all smaller integers than minus 1.5. So minus 2 is the largest, right? In this way, you can understand this function. Now discuss the continuity of this function of f. Now, first of all, try to understand this function geometrically in detail. So f of x is equal to, suppose uh, 0 less than or equal to x less than 1. What is the function? 0 to 1.
0.
Right, any x in this, so the integer greatest is 0. But at one value of this function is 1. F of 1 is 1. Right? And therefore from 1 to 2, what is it? Up to 2. If I vary my x from 1 to 2, at one value of function is, right, at 1 value of function is 1. And what is the value of function at 1.8? Is also 1. Right? But at 2, value is not 1. It is 2. So in this way, you can see this. And therefore, in general, from n to n plus 1, what is the value of function n? Correct? And on the negative side, what is the value of function from minus 1 to 0?
Minus 1.
Minus 1. Right? At 0, it is 0. So what is the value of function from minus 2 to minus 1? It is minus 2. And therefore, minus n plus 1 to n minus n. What is the value of function? Minus n.
Minus n plus 1.
Right, so this is a clear idea we understand about the function. On each part, how is the function? And if you try to sketch the graph of this function, right, if you try to sketch the graph of this function, 1, 2, 3, -1, -2, -3. So 0 to 1 it is 0, right? So 0 to 1 function is 0, but at 1 it is not 0. So at 1 it is 1, right? Up to 2 it is 1, but at 2 it is 2, right? But up to 2 it is 2, but at 3 it is 3, and so on, right? And -1 to 0, -1 to 0 it is
Minus
how is
one.
-1, but at 0 it is 0. So -2 to -1, how is it? It is -2, but at -1 it is -1. So -3 to -2, like this. So this is a graph of function. Now we can understand where this function is continuous and where it is not continuous. Where it is continuous,
R minus integers.
right? So the first thing, f is continuous at half, right? That you can understand easily. F is not continuous at 1. Why? Because limit x tends to 1, right hand limit of fx. What is the right hand limit at 1? Is 1.
2.
Limit
It's just 1.
left hand limit at 1 is from the
0.
figure 0, right? Therefore, limit x tends to 1, right hand limit is not same as left hand limit, right? Therefore, limit at 1 does not exist, so not continuous at 1. Similarly, at other points. So, for n belongs to integers, right? Limit x tends to n of fx is not same as limit x tends to n minus, right? Therefore, limit x tends to n fx does not exist, right? And why this right hand limit is not same as, you try to write down it explicitly as like 2 n is equal to 1, we write it as one side limit is 1 and another side is 0. So at each end you write down the general way to say that right hand limit is not same. So therefore f is discontinuous at each n belongs to z. And therefore, what is the set of points of continuity? On. And if you choose right, that means those x such that x is not in integers. So if you choose a non-integer, then it is continuous. So that is obvious. But now we want to understand more. So let g from R to R, g of x is equal to x minus this greatest integer function. Right. For example, what is g of 0 is 0 minus it is 0. But what is g of 1? 1 minus greatest integer value. What is it?
0.
0. What is g of half? Half minus.
Half.
What is greatest integer? Is half minus 0, which is half. So that, can you write down it explicitly? If at 0 it is 0, right? So 0 less than or equal to x. At 1 also it is 0, right? At 1 it is 0. So at 0 it is 0, at 1 it is 0, but whatever in between, for every value in between, what is it?
X.
X. So if 0 less than or equal to x less than 1, right? Then what is g of x? It is x minus greatest integer value. But if x lies in between 0 and greatest integer value is 0, so x minus 0, which is x. Right, but at 1, it is 0. Now, what after 1? What after 1?
X minus 1 up to 2.
So 1 less than x less than 2. Right, so if x lies in between 1 and 2, x as it is minus greatest integer value is 1. So x minus 1. So, and what is value at 2? 2
0.
minus greatest, so 0, right? At integer value is 0. So extend this, 2 less than x less than 3. In this, x minus 2, correct? And so on. And that 3 value is 0. So continue this. Now what about negative side? So minus 1 less than or equal to x less than 0. So what is x minus absolute value of x? So x is greater than or equal to minus 1. Then what is it? X. And what is the greatest integer value for such x? Minus
Minus 1.
1 to 0, minus 1. But here it is already minus 1. So x plus 1. At 0, we know that value is 0. And what is value at minus 1? What is the value at minus 1? Okay, let us take x strictly greater than minus 1. And if x is equal to minus 1, okay, you can include here also, but anyway, it is 0.
Ma-
Right? If x is equal to minus 1, it is 0. So in this way, you can understand the function. Now let us sketch the graph of this function. So in calculus, you should always try to sketch the pictures so that you can understand functions. So, okay, let us see how is the graph. From 0 to 1, right? It is x. 0 to 1, it is x. At it is at x. At 0, it is 0. At 1, also it is 0. But 0 to x function is f of x is equal to x. And how is the graph? In 0 to 1. Yes. And at 0, it is 0. Is it correct graph?
yes, sir.
Now at 1, it again falls down to 1, to 0, because at 1 value is 0. But then after that, what is the nature between 1 to 2? 1 to 2, it is like
Same as 0 to 1.
y is equal to x minus 1. Y is equal to x minus 1. That means what is the nature at x is equal to 1, y is 0. That means same nature, just shifting, right? And at 2 again it falls down. At 2 again it falls down to 0 and up to 3. Right, so this is the nature of function. On the negative side, right, at -1 it is 0, but how is the nature between uh, -1 and 0? How is the nature? If x is -1, it is 0. Yes.
Same like 0 to 1.
So intercept is 1, right? So y0 x is -1. Same nature. Slope is c. Y is equal to x plus 1. But at 0, it is 0. And at -1 also it is 0. So at 0, it falls down. Similarly, -2 to -1. At -2, it is 0. So this is a nature, or this is a graph of function. And now you can understand where this function is continuous. Then if n less than x less than n plus 1, then f is continuous at x, whatever n you select. Is it correct? If x is strictly in between, you choose any x in different from integers. Or if x is not in z, then f is continuous at x. Second, if x is equal to n integer, then what is limit x tends to n from right side, and what is limit x tends to n from left side? Are they same?
No, sir.
So right hand limit at each integer is always 0, but left hand limit is what? What is
1.
left hand limit at is always 1. So not same. This is true for each integer. Therefore, f is not continuous at n in C. So in this way, you can understand the points where this function is discontinuous. Right? Yes, now let us see some non-trivial example. See, if you define if f of x is equal to 1, if x is rational, and 0 if x is irrational, so r minus rational. Then what can you say about this function? What can you say about this
It
function?
is discontinuous.
Everywhere, right? Then limit x tends to c f of x does not exist. Or at any point c limit does not exist. Do you remember this? We already discussed this. Therefore, f is discontinuous at each real number. that is f is discontinuous everywhere. On R. That means this function is a kind of very bad kind of function, so it is discontinuous everywhere, right? So, question, can you give an example of a function f on R which is discontinuous everywhere on R, but the absolute value of f is continuous everywhere. On R. So the question is clear.
Sir, f is equal to 1 if rational and -1 is if irrational.
Right. Very good. So f of x is equal to 1 if x is rational, -1 if x is irrational. Then f is discontinuous at each x in R. And why? What is the reason? Same reason which we discussed earlier. Yeah, if you choose any C, there is a sequence of rationals and irrational converging to C, but f of x and f of y does not converge to same number. Now, what is the absolute value function? What is it? What is this function?
1.
1 if x is in rational and absolute value of -1, which is again 1 if x is in irrational. Therefore, absolute value of f is 1 for every x in R. Either it is rational or irrational, doesn't matter. This function is always 1. And therefore, this is a constant function. Therefore, f is continuous. Absolute value f is on R. So at each point, constant function is continuous. Right? So there is one more very interesting function. The question is, does there exist a function f on R which is at each rational number and discontinuous at each irrational number. So question is clear. Okay, before that, does there exist a function which is continuous only at 0?
Yes, sir.
Does there exist a function continuous only at 0? So answer is yes. Does there exist a function which is continuous only at 2 points? Answer is yes. But this question is difficult. Does there exist a function which is continuous at each rational and discontinuous at each irrational? So answer of this question is actually no, right? Answer of this question is no. And why that is a difficult to answer immediately, but you can think about it, how to prove it. For that you need some more analysis. So but the question is, does there exist a function f which is continuous at each irrational and discontinuous at each rational? So answer of first question is no. Answer of first question is negative, but answer of third question is positive. Right. This is a very interesting fact. There is no function which is continuous only at rationals and discontinuous at irrationals. Right. But there is a function which is continuous at each irrational and discontinuous at each rational. So do you understand the difference?
Yes, sir.
And so this is, and here is the example. So define on R what is fx. Fx is 1 by q if x is a rational, x is equal to p by q, right? So if x is a rational, then every rational is of the type p by q, right? Do you understand? If x is a rational means it is p by q and then value of function at p by q is 1 by q. 0 if x is irrational. Right. So function is 0 and or x is 0. So either x is irrational or 0, then value is 0. At other rational numbers, it is 1 by q. For example, what is f of 5 by 3?
1 by 3.
1 by 3. Right. So what is f of minus 5 by 3? Yes. Okay, let us make our job easy, because to avoid confusion, I will define on 0 to infinity. Now here everything is positive, but in general I can define it as 1 by 3, because uh, if p is negative, I will if my rational number is negative, so I will assume denominator always positive. So if it is my negative rational number minus 5 by 3, I will just see it as p is minus 5 and q is 3. But anyway, to avoid this, let us think about it is defined on positive, non-negative real numbers. Anyway, so now we can understand. So what is f of root 2 is 0, because at every irrational it is 0 and at rational it is of the type. F of 37 by 150. What is the value of function?
1 upon 150.
150. So okay, so here we have to make one more assumption. GCD of P and Q is 1. That means we assume P by Q in the least form. Whatever is common, cancel it out and then look at Q. What is the denominator? So what is f of? So therefore, what is f of 10 upon 12? What is f of 10 upon 12?
1 by 6.
1 by 6.
1 by 6. Because whatever is a common, that we should cancel out first of all. So what are the 2 is common? So 5 by 6, and therefore it is just 1 by 6. This is not 1 by 12. Remember. Right, it is 1 by 6. So in this way I define the function, and then the aim is f is continuous at each irrational and discontinuous at each rational. Okay, so our time is over, so we'll stop here. We'll see this later on, right? So if you have any doubt, you can ask. So
Sir,
yes,
so what is the portion for tomorrow's test?
limit.
Till today's topic.
Yes.
Okay, sir.